Alright guys, so we are going to start this section 3.4 part 2. I decided to work with you a little bit the problem number 3 and 4 and of course as well as 5 and 6. So for number 3, please, what you need to focus on is trying to have a proper way to draw your problem. This is rotating as 152 rows per minute. That is what we call the connecting bell. Okay, that is the connecting bell. Let me write that better. Connecting bell. Belt. Why do I say bell? Belt. And obviously, if I turn this way, my belt is going this way on a linear speed. So, if I want to just a few things that you need to focus on. First of all, the velocity of the small pulley is equal to the velocity or the linear speed of the big pulley, which means that we had WS times the RS for small equal WB for big times R big. And I'll let you finish the calculation to find the value of small. You have to convert that. No, you don't. You don't need to convert 152. You can leave 152 for W big. Okay, and remember what you're looking for is WS. So express WS from there, substitute the value of RS, WB, and RB for big, and you will find the value. Now let's figure it out for the second problem, number 4. Alright guys, so now let's talk about the problem number 4. In the problem number 4, a bicyclist pedals at 100 RPM. The front sprocket has 51 teeth. I'm going to call that the big circle, and the rear sprocket has 13 teeth. The tires have 13.0 inch radius. Find the speed of the bicycle. So first of all, we can talk about the angular speed. Angular speed. Oops. All right. So now if I look at the velocity, the linear velocity, linear speed, we have V of the front socket equal V of the rear socket, and V of the rear socket both defined by WF or F. So now I can easily express the angular speed of the rear socket. It's not socket, sprocket. It's not a socket. I divide by R both sides, so I got WF multiplied by RF divided by the radius of the rear socket. All right. The radius is proportional to the number of teeth. Okay, the radius are proportional to the number of teeth. Therefore, when I'm calculating this this angular speed of the rear sprocket, this is going to be 110 RPM for WF multiplied by 51, which is the number of teeth for the front, for the radius of the front socket, divided by 13, which is corresponding to the radius to the rear socket. Remember, radius are proportional to the number of teeth. So when I do this calculation, end up to have, at the end of the day, oh, before that, I'm sorry, but you need to remember 110 is defined as RPM, revolution per minute. Therefore, I need to convert that into radian. And to convert that into radian, I need to multiply by 2 pi, because 1 revolution equals 2 pi. So when I'm calculating WR equal 110 multiplied by 51 divided by 13, I'm finding equal to 431.5 revolution divided by minute. But if I want to convert revolution into radian, I will have to multiply by 2 pi and divide by the number of revolution, which is 1. 1 revolution equal 2 pi, and therefore I end up to have a value equal to 2711.4 radian per minute. Now that I know the value of the angular speed of the rear sprocket, I can calculate the velocity v, the linear speed. V is equal to, so the linear speed now, and so the linear speed v equal omega multiplied by r. V equal 2711.4 multiplied by 13.0 inches, and that gives me a linear speed of 35,250 inch per minute. If I want to convert that in foot, well, I will let you do that. Convert that into foot per minute. And you will have a questions in that puzzle. Again, you can also try to transform that into mile per hour. So try to convert that into mile per hour. Okay? All right. So now let's go and try to work on the problem number 5. A satellite 1800 kilometers above the Earth's surface takes 2.5 hours to orbit Earth. Find its linear speed. Well, I know that the linear speed is going to be the distance, can be also defined as the distance divided by the time. And the distance is going to be the circumference divided by the time necessary to do this, to do the orbit, to be in orbit around the Earth. And this time, regarding the circumference, I know it's going to be 1800 kilometers. First of all, what is the circumference? Well, the circumference equals 2 pi multiplied by r divided by the time. R equal the 1800 kilometers plus the radius of Earth. If I translate all of this distance in mile, R is going to be equal to 1098 miles. That is the conversion of 1800 kilometers into mile, plus 3960 miles for the radius of Earth. And that is going to give me a 5058 miles. And now I can calculate V equal 2 pi multiplied by 5058 divided by 2.5, as they are telling me that the satellite above the Earth's surface takes 2.5 hours to orbit the Earth. And we end up to have 13,000 miles per hour. Question number 6. On this question number 6, geostationary always 35,786 kilometers above the Earth's surface and are stationary above a given point on the equator. So, if I represent... again, this is not what I'm looking for. I want to graph the Earth. So, let me do this. There we go. So, if I want to represent the Earth, there we go. Now, I'm going to represent the equator. And if I am on the equator right here, knowing that is the radius, geostationary satellite will be above this point, rotating. Let's see, it's going to rotate like this way. Now, what is omega? What is the angular speed? The angular speed of this satellite, omega equal 2 pi divided by 24, which is pi over 12 in radian per hour. Radian per hour. Now, if I want to define the distance, I need to take the radius of Earth right here. This is the radius of Earth plus the altitude where I'm at. Well, obviously, what we are going to call the wall radius is going to be the 3,960 mile. Remember that you need to translate the 35,000, convert the 35,786 kilometer into mile. So please don't forget that. And you are supposed to find 21,829 mile. Please convert and try to make sure that I didn't make any mistake. And you end up to have a radius of 25,789 miles. Therefore, when I'm going to calculate the linear speed, it's going to be pi over 12 multiplied by 25,789, and I end up to have a 6,800 mile divided by hour. Okay, so I think we cover pretty much everything. Let me just rewrite this 800 in a better way. So we found this. I'll let you work in class. Take your time and everything will be all right. See you in class.